In this video, we're going to discuss how the Plotclock works, and we'll be doing that from the software point of view and explaining using a block diagram how that happens. And it's really quite simple. There are 560 lines of code in the Plotclock software, but it can be broken down into several easy to understand pieces. So let's get started. First of all, we have the first lines 1 through 138, which are for initialization. The first thing the Plotclock does when it's powered up is the particle core will go to the internet and it will handshake with the particle cloud, and from there it gets the time from the internet, so it knows what time it is currently. Then there are many comments within those first 138 lines explaining how the project works. Then there's some statements for includes or libraries which call other pieces of software code that have been written by others that we include in our project so we don't have to rewrite code. In particular, there's an include library for the servo driver from Adafruit, and there's also a math library so that the program can do trigonometry functions. And finally, we define variables with the names and their initial values so the Plotclock knows what to use for variables. Next, what happens in the lines from 139 to 192 is the setup section of the code. From there, we set the time zone, and we also tell the core to begin using PWM, which is pulse width modulation. That simply means we use some of the output pins to give it variable voltages in the form of pulses, and it can understand by communicating in a serial fashion how to tell the servos what to do. After that, we move into the lines 193 through 251, which is the loop that never ends. This is the infinite loop that the Plotclock finally gets to when it starts running. And what it does is it looks and sees if in the setup portion we asked it to run the calibration loop. It'll do so if we instructed it to do so. If not, it says we just run the normal subroutine once every minute. And that subroutine can call a number of different functions depending what the time is. So let's go over the different subroutines. So we've broken up from the main loop into 6 different subroutines or blocks. And we should note that any of these blocks can be called on from the main loop at any time. And while some of the blocks are running, they may call other blocks. For example, the number block, which draws the numbers, often calls and uses the draw to block, which we'll explain in a little bit. So, first block we're talking about are lines 255 through 376, which we call the number block. This instructs the Plotclock how to draw each numeral, how to make a colon symbol, and then how the sweeper should function when it's going to erase the board between each minute. Then next we've got the block that are lines 380 to 472. That's the lift block. And lift tells the Plotclock how high to lift the pen in each case. So there's case 0, where the pen should be on the drawing surface, which needs to be tuned in when we calibrate. Case 1, the marker height between the numbers when it's lifting up and it doesn't want to be on the surface so that we don't drag the pen. And case 2, bringing the pen up even higher so when it heads towards the sweeper it doesn't run into anything. The next block is 475 to 486. This has a bit of a German acronym that I didn't figure out what it stands for, but it basically means it's going to be called on anytime a counterclockwise curve needs to be drawn. So that's what that block is used for. Conversely, you have lines 488 to 498, which does just the opposite. It will draw counterclockwise curves, so you'll see that in the code. Then in lines 501 to 521, the draw to, that's just when you want to get a straight line drawn, and it'll call that block out. And then finally, 528 to 560, there's a lot of math going on here. The set XY block, and that calculates from where the pen is currently to its next point, how will the pen get there? And that's where the math is all done. So that's really, in short, how the Plotclock works. It's not all too complicated, but you can see it has many different small blocks that work together and forming the digits and then erasing the routine, and it does the same thing over and over in the loop block.